Okay, hi everybody. My name is Tim Gross. That's my Twitter handle, if you want to Twitter at me. I work for Joyent. We're a subsidiary of Samsung. We operate a public cloud with global data centers. Everything we do is open source. So you can take the same software that we use to run our public cloud and run it in your own data centers, but it's way cooler than OpenStack. Our customers include some of the world's largest customers, or largest retailers, yeah. But this talk is going to be a little ranty, so it's really not about the work that I do on a daily basis. I want to talk about software and culture. You have to be a little careful when you talk about culture, though, right? Because culture is the sort of thing that people can get very offended by. People have very strong feelings about it. And as technologists, we have a habit of being incredibly tone deaf, right? I will admit to have being guilty of this myself. In this talk, I'm going to poke fun at some technologies that I've used, some of which I even like. If I don't include your favorite technology, it's not because it's any good or bad. It's just because I haven't personally used it. So Bridget, who is just up here on stage, is fond of saying, containers won't fix your broken culture, right? And she's right. I was at a Velocity conference in New York last year, and Catherine Daniels was on stage. She's the co-author of Effective DevOps, which is a great book. Everybody should read it. And she was saying tools will not fix a broken culture. And she's right. And this is basically the problem that we're facing right now in technology, right? We have an embarrassment of riches in terms of technical tools and best practices, but none of it really fixes the human problems that we have. It doesn't even fix most of the technical problems that we have, so it's not very realistic for us to assume that it could fix our cultural problems as well. So I live and work in Philadelphia, and like many cities, we have a Slack, Philly Dev, and there's of course a DevOps channel in there, right? And every so often, it seems like once a month or so, this exchange more or less happens, right? A very excited new person comes in and says, hey, I've been instructed to do DevOps at our company, right? I don't really know what that means, so should I be using Puppet or Chef, right? And maybe the conversation is not as constructive as it could be, right? This could probably have been handled a little better. But the point here is that JRandomOps person is telling the excited new person that they're confusing tooling for the model of working, right? This is going to be a bit of a weird analogy. Anybody here do yoga? Yeah, a few? Okay, good. Oh, that's great. There's a particular practice called Kundalini Yoga, and some practitioners of that call it a technology. It's kind of an interesting idea, which is that it's a practice. It's a human-created practice a tool rather, that we use to improve ourselves, to improve, generally speaking, ourselves as individuals, but perhaps the people around us. But there's this notion that people talk about in kind of the mindfulness community called spiritual bypass. And the idea here is that rather than doing the real work on yourself, right, actually self-improving, you kind of just use the tool, right? So like, I have green juice in my fridge, but I don't actually drink it, right? I go to a yoga class, but then right afterwards, I'm lighting up a cigarette and gossiping about people on Twitter, right? So in that case, like even better than just using the tool, you're surrounding yourself with the trappings of the tool, right? I am the kind of person who uses this tool, so therefore I'm good. So a lot of the tooling that we have in this kind of DevOps universe, this obsession that we have, is a form of this spiritual bypass just as applied to technology. Using the tools do not themselves turn you into a successful organization, right? Like that's not enough to implement the cultural changes that we need. And the reason, a lot of the reason behind this is something called Conway's law. So this is from Melvin Conway. I think it's back in the 60s. But the idea here is that an organization that designs a system, and this can be information systems, but can be larger systems like the cultural and organizational systems that we create, will produce designs whose structure are a copy of the organization's communication structure, right? This is also sometimes called shipping the org chart, right? Has anybody, I don't have it up here, but has anybody seen this, like, it's the org charts of different, like, major tech companies, right? And it's like Microsoft, and they all have guns pointed at each other, and it's like Google, and they're all like this big thing. And like, the way that we build our technology is influenced by the kind of the structure of our organization. And so in a broader sense, I'm saying that, you know, we say, and I think we all kind of agree, people who are in this room probably at least, agree that our culture influences our technology. And so this is our shared assumptions, our shared values, our shared beliefs, how we make decisions influence our technology. But, I mean, this is a talk called software-defined culture, right? So clearly there's a but here, right? Which is I'm going to try to go in the opposite direction here. Culture is a very complex system, though, right? It's subject to chaotic feedback. Instinctively, I think we all know and probably agree, if we think about it a bit, that bad technology choices can influence our culture. If we don't build reliable software, right? If that isn't baked into the core of our software, our operations team will probably hate the guts of our development team. Well, that's technology affecting our culture. If our operations teams build software that builds delivery systems that aren't self-serviceable, right? So that everything that a development team needs to deliver involves this like annoying change process, the development team is gonna hate the guts of the operations team. We know that if we don't build for flexibility and rapid delivery, that the product management team is going to be very frustrated with the development team. And kind of like on and on through the different iterations, the different kind of permutations of the different groups that we can have in our organizations. My favorite column here is the sysadmin column, as an ex-sysadmin myself. If we spend our entire weekend up all night because pager duty is going off and waking us up, and then we all come in on Monday morning, and we're all snipping at each other, and we don't like each other anymore because we've ruined each other's weekends, we have a case where technology is influencing the culture of our organization. If we start ignoring our mail because we've done something silly like, let's send all our meeting requests and all our inter-team chatter and all our code reviews and alert messages, and I've seen this actually happen once, all our HTTP 500 error stack traces through email, so that we then start just ignoring the email, right? Technology is influencing our culture. If we can make decisions and have communication that's asynchronous, that gives us a little more time to think, that allows us to have a distributed team, technology is influencing our culture. There was a great blog post earlier this month, Bill Higgins, an IBM distinguished engineer, where he was talking about a new project that he had started at IBM and bringing in kind of more modern tooling to this team. And he saw a really radical change in the way that the team worked with this new tooling. And this quote starts with magic, and he uses the word magic like 8 times in this blog post because it made a major difference for his team, right? He says all the tools we used had excellent surface usability, right? Like these, the tools that are coming, and I'm gonna pick on Silicon Valley here, right? Like there's a lot of beautiful tools coming out of Silicon Valley right now. But the magic was in the new workflows and collaborations that they enabled, right? GitHub, yes, is a pretty UI on GitWeb, right? Like, yeah, I can do GitWeb on my Debian server, and like I've got GitHub, right? It's basically the same thing. It's not, right? When you buy into this pull request-based workflow, you've enabled social coding within your organization, right? You've allowed for greater peer review. Slack it's just a pretty UI on IRC, right? Isn't it just the same thing? But the magic, as he was saying, was that it becomes this touchstone for the whole team, and not just the technical team, but the technical team with the non-technical teams, who aren't gonna get in and log into IRC, by the way, and also the CI/CD tooling that can interact with it as well. So Conway's law tells us a lot about the cultural influences, how culture influences tools, but tools also influence culture, right? And so there's this back and forth. There's a great quote in this discussion a few years ago by some Etsy engineers who did a Reddit AMA, of all things. And there was actually a really good discussion that came out of that. And they talked about this kind of inherent back and forth between tools and culture. So while kind of thinking about this idea, I've come up with what I call 4 principles for software-defined culture. And maybe principles is too grandiose for you. We can call them guidelines or whatever, but that's what I want to talk about. And they're building for reliability, building for operability, building for observability, and building for responsibility. When I first wrote this up, the last one was build for impact. And I gave it to a friend of mine who's in marketing. I was talking to him about it, and he's like, no, it has to be an ility. Like, they all rhyme. So that's why I don't work in marketing. Okay, so the first one is building for reliability. A failure to build for reliability as kind of the core concept of how your design is built leads to firefighting, right? And firefighting becomes a rut for organizations. The patch fixes that we make for problems today are all kind of like temporary hacks, which means that the problems come back and they grow, right? We have the zombie bug that keeps coming back. In this environment, everything becomes urgent, which means that the things that are important to our organization, and by which I mean our long-term goals, the things that provide business value for us, those go by the wayside while we're constantly fighting fires. And without a culture of reliability, we misalign the incentives of the team, right? Rather than rewarding the creation of business value, we're rewarding the prevention of largely self-inflicted harm, right? And this is going to lead to burnout on your team, right? So the people who are your best firefighters, the hero worship, right? Sometimes we've seen this. This is a really common pattern in operations teams in particular. They're going to burn out. The people that we bring into our organizations came to your organization largely because they agreed with your mission, because they wanted to do work on interesting problems, right? Like, nobody would go through the typical tech interview process if they didn't actually believe in your mission, right? Like, they would find some other easier place to go work, right? We know how organizations hire, right? So people don't like to be paged, right? Like, they didn't come to do a bunch of patch fixes. They came to bring some kind of value to your mission. So you're going to lose people to this, and you're going to lose your best people to this. You'll lose them to either them just quitting, or actually them burning out and having their work suffer, right? Where it becomes time to maybe have uncomfortable conversations with them. And what's very strange about this is because these people were typically your best people beforehand, right? They were your best firefighters. They're going to leave and it will be a surprise to you because you won't understand why. They seem so happy, everything was going so well. So this starts to guide our technology choices, right? Like this principle can guide the way that we make decisions about how we select technologies. So for starters, let's stop with the resume-driven development, right? New software, new technology is broken all the time. It's almost by definition, right? Like until people have worked with it a lot, we don't know how it's going to work. This is going to normalize risky decision making, right? So like if it's okay for your developers to say, hey, this week we're gonna start a new project in Elixir or Aerospike DB or Vue.js, or we're gonna rewrite the whole front end in Vue.js this week. If that's okay, and it isn't vetted and it isn't done in internal tools, development tools, rather than just kind of YOLOing that into production, you normalize risky decision making, right? And you're telling people this is how you get rewarded, right? You shipped the new thing that we rewrote the whole front end for no reason, for no business value at all, right? A kind of subtle effect of this, and that can be very toxic in organizations, is that this attracts like-minded hires. People who there are some people in our industry who only really like to work on new things. They don't really like to maintain things. And they will tend to attract people who are like them to your organization, where they can get away with this. And then they'll leave when the fun stops. I'm gonna tell a slightly anonymized version of this story that I've witnessed. So I was at an organization and a senior engineer brought in, a very good senior engineer, said, I really am interested in this new programming language. I want to introduce it, and he convinced the CTO to go along with it. It doesn't matter for the purposes of the story, but it was Go, which tells you a lot about the kind of decision making involved there, perhaps. So they said, okay, well we want to switch all the new stuff that we're building. We're gonna write all that in Go, and it will be all our new software. And so he started to bring in people from other organizations that he had previously worked with, who all wanted to work on this new stuff with him. And they ended up building a lot of kind of toy implementations of production software, right? They didn't really care or know how they were going to handle logging, how they were going to handle dependency management, how they were going to deal with health checking, for example. If you're running an AWS ELB load balancer in front of these things, like, you shouldn't return 200 OK if you're not OK. Just, and what ended up happening is that software was all built, and they got bored, and they left. And they all kind of one by one left, and they went on to a new company, largely together, right? And so the company, the organization was left with this kind of like crap code that these people had left behind. And this isn't I've talked to other people, and this is a very common property where you end up with this kind of like plague of locusts of people who like to work only with new technology. Which would be okay, but it doesn't provide any business value to you at all, right? Like this is, and it increases your hiring costs because they're going to leave. This kind of resume-driven development is going to end up biasing you against experienced hires. They've already been through a couple of burnout cycles, right? If you've got somebody who's been working for 20 years, they've probably been burned out at some point. Just quick aside, that's really messed up, by the way, that we're like, yeah, totally. Like they've been in 20 years. How have they not been burned out yet? It's going to bias you against older hires just in general. Maybe if they weren't experienced, but like inexperienced, but second career types. People with families, right? Like if people with families, generally speaking, don't want to be up all night debugging your software because you decided to like swap out for the MongoDB newest storage engine and you only tested it for 3 days, right? Like that's not going to keep these people in your organization. So we need to talk about, so how do we solve that? But we know that we need to innovate, as technologists. So one of the kind of anti-patterns for trying to solve this is called bimodal IT, right? So we have one group of people in our organization. You see this a lot in large enterprises, right? So we have one group of people who get to be the innovators. Sometimes they'll be called like the labs group or the innovation lab. And the other group of people who get to work on like the production software, right? And I've seen this called awesome mode versus sad mode. I think Bridget told me that one, right? And it should be obvious what this does to your morale, right? Like you have people you've hired in as technologists, and like these are the people who get to work on the cool stuff, which, by the way, probably will never actually go into production. And these people have to get the benefit of saying, oh, we get to work on cool production stuff, but we don't get to learn anything new, right? So without a culture for reliability, we have misaligned incentives, right? We're at risk of creating a culture where we simply lurch from crisis to crisis. So we need to choose where we innovate wisely, right? And we have to choose to innovate where it's going to have the most business value for us. Okay, the second principle, building for operability. And I'm really mostly talking about orchestration here. Monitoring and debugging, I want to talk about a little bit later. So having automated build test workflows, reliable deployment, easy scaling, ideally in kind of a self-service push button sort of way. When developers can provision resources that they need without having to go through some kind of like approval process. This is really great for their morale, of course, but it also, in systems where it works very well, everyone has their own kind of like staging test environments. You have a lot of velocity in how you can deliver your software. And it empowers our development teams. And promotes shared ownership over both the infrastructure and the code. So one of the models around this, one of kind of the notional frameworks is this, GIFY, Google Infrastructure for Everyone Else. And it sounds like a cool idea. And there are some organizations and projects that kind of are associated with this, so Kubernetes and CoreOS. And if you are building a distributed system of microservices that only speak HTTP to each other, does anybody building a piece of software that only speaks HTTP, right? Everybody has a database, probably. But maybe this is the right answer for you if that's the case. But when you're taking on, I want to do things the way Google is doing, you're taking on all the cultural baggage from them, right? They are not the same as your organization. The application behavior becomes split between the application and the platform, right? Which are typically, in most organizations, as much as we would all like to believe otherwise, are going to be managed by two separate teams, like a development team and an operations team. And because the application behavior is split between the application and the platform, the application developers can no longer fully understand how their application works without the underlying platform, right? Often the developers will not run the platform in their local development environment, often just because it's too heavy, right? There's too many things involved with it. which is going to bias them towards unit testing and so-called integration testing, which is really like, well, my service works and I have a bunch of mocks, so it must work, right? A lot of these platforms require some kind of integration code between the application and the platform. That code is generally not going to be portable between different platforms, which means that operators get locked in and they can't make decisions to change platforms based on cost and infrastructure reliability. So this tight coupling of all the application components, right, the application, the platform, and this integration tooling has actually recreated a lot of the same problems that we were trying to solve by using these kind of cool platforms. Instead, we could consider an application design that allows for applications to be self-contained and self-operating. I've been working on a project at Joyent called Autopilot Pattern, which is the idea that applications should share with the infrastructure responsibility for their lifecycle: startup, shutdown, scaling, discovery, recovery, telemetry. The applications can be more intelligent. There are a couple tools that can help you out with this. Container Pilot is a tool that I've written, and an open source project that we've been working on. There's also Chef's Habitat is an excellent example of this same design. Habitat from Chef acts as a process supervisor. It triggers lifecycle events and gossips service discovery and configuration changes. And Container Pilot triggers lifecycle events and gossips service discovery and configuration changes. So there's actually kind of this interesting parallel evolution between the two projects. Both are pretty cool. I'll of course say check out Container Pilot because I wrote it. So by having the application own more of its lifecycle, we can achieve stronger platform independence. And platform independence allows for more laptop-friendly orchestration, right? So if the behavior of the application is as self-contained as possible, then that means that the application developer doesn't have this works on my machine problem anymore. I'll talk about two examples where this has worked out. One has worked and one has hinted that it might work. So there's an organization I worked with recently to implement this pattern, a large retailer. And the head of their platform team, so they had this a terrible anti-pattern, right? So they had an application development team and a sysadmin team, and then an infrastructure or DevOps team in the middle, right? Or the platform team. And this poor guy was basically getting kicked from both sides on a daily basis. And he said to us, I get told I'm a roadblock 100 times a day. Kind of a miserable situation. So he brought this pattern to the application development team. So he was in charge of the underlying platform, which of course was our platform. But by bringing this model to the application development team, they were able to make their software more operable and more understandable. And so it empowered the application development team, and now that platform team is seen as facilitators rather than roadblocks. The sysadmin team, we still haven't won over, but we'll get there. I presented this pattern to a government agency recently. I can't say who, so we'll just say it's these guys. And during the meeting, so these large government agencies work just like large enterprises, right? There's all these little fiefdoms that all hate each other. And during the meeting, kind of an argument broke out, and with all the different managers kind of pissed off at each other. And one of them said, the thing with this is that it makes the application developers responsible for knowing how their software works in production. And I said, yeah. And this was pretty much their reaction. I don't think that's in the Unicode standard yet. So both the application development teams in that room and the operations teams were like, whoa, now we're onto something right here, because this actually gives both sides what they want. And then there was kind of this bright flash, and I don't remember what happened after that, but I think they implemented it. All right, so the idea here is we're going to make the production behavior of our application understandable by the application team. And so this will empower our development teams to operationalize their applications. So Google infrastructure is probably awesome, but does it solve a problem we actually have? Okay. The third principle, building for operability. So I think in this room, right, we're all, the kind of people who come to a DevOps track at a conference, right? We all know we need to monitor all the things, right? You even know what what the image is missing here, monitor all the things. Okay, we know that. This is a quote from my CTO, Brian Cantrell, who will actually be doing the keynote tomorrow. This was in ACMQ 11 years ago now. We have built mind-bogglingly complicated systems that we cannot see, allowing glaring performance problems to hide in broad daylight in our systems, right? But now this is 11 years ago. Well, now we're building everything with microservices, right? So we have these really complex distributed systems. So every bug is now a murder mystery. Like, who did it? I don't know. Was it the cache layer? Was it the, right? We don't know. And because these systems are distributed, many of the most difficult problems that we're going to face in trying to debug are only ever going to happen in production. So, what I was saying earlier about laptop orchestra, or being able to orchestrate on your laptop still holds, right? Because that's just your table stakes. Like, if you can't understand how your application works on your laptop, well, then you're never going to understand how it works once you go to production. And but debugging in production means that we need to be able to debug safely, right? If the observing of the system changes the behavior of the system, kind of in that, what's that, Heisenberg kind of way, right? If it changes the behavior of the system, or worse, causes it to crash, then we can't reliably use it to debug the behavior of our systems. So it's time to move on from the dashboard, right? Dashboards are great for telling you what you already know, your known knowns, or maybe your known unknowns, right? But they're not going to help you with that unknown unknowns from that quote I had earlier. So instead, we should be selecting tools for monitoring that allow us to explore and to discover what's going on. This is a very awesome blog post about a year ago from John Osbaugh from Etsy, an open letter to monitoring metrics and alerting companies. Right? This is an organization that knows a lot about this stuff. Right? They wrote StatsD. And he's basically saying, hey, folks who are building monitoring tools for people, this is what I'd like to see. Take as a first design principle that outages and other untoward events are handled not by a lone engineer, but are more often than not handled by a team of engineers, all with their own different expertise, right? So we shouldn't, right now the tooling that we have is all optimized towards how do one person digging into this, but it isn't optimized around working with a team. Monitoring tool selection can be a way to improve communication and create durable and persistent records of that communication. Not of our communication, but of our exploration and discovery of the problems that we're trying to solve. This is a screenshot from a new company, Honeycomb.io. They're building a tool that is an answer to John Osbaugh, I think. The idea here is that you send all your logs to it, and it allows you to iteratively build up queries on those logs. And as you're doing so, and I kind of cut it off here, what it's doing is it's creating a playbook as you go. So you're exploring through here, and you can take that playbook, and now you have a record of how you debug the problem that you can share with other members of your team, and it becomes an opportunity for mentoring. It becomes an opportunity for training, an opportunity for communication and postmortems as well. Check that out. It's pretty cool. Monitorability should be considered a functional requirement of our systems. This is an embarrassing story because it's my story. So this diagram is DFSR, Distributed File System Replication, which is something in Windows, back when I used to do Windows stuff. It's an eventually consistent-ish WAN replication of block storage, which is just about as bad as an idea as you can imagine. We were running it where we had a main office and then a bunch of satellite offices. And the idea is, of course, that the end user experience that the end users are expecting is I save my thing and then it shows up in the other office, right? That's kind of like what they want. But replication performance between our different satellite offices, this is before the getting getting reliable high-speed internet to some of our satellite offices at the time was very difficult. This is like 2008, 2007. And file system locking over the WAN was basically a farce. And we had some software that we were using that was, didn't expect that you were trying to do file locking over the WAN, because why the hell would you do that? And that caused a lot of problems for our users. And so this was really problematic for us. And the reason it was really problematic is because when we tried to get into figuring out what was wrong with it, there was no monitoring, right? There was no way for this thing to tell you what was wrong with it. You could bring up you had this thing where it could say, okay, bring me up a report of what's going on. And it would bring up this thing that was like a web page that you could view only in Internet Explorer, of course. And it told you, here's how much bandwidth you're saving with our compression algorithm. That was the monitoring. That was it, right? In the last month, it's like, thanks, that's very helpful. So we went through what I call the 5 stages of unmonitorable systems grief. Denial, well, we don't need to monitor that. Anger, why aren't we monitoring that? Bargaining, and this was where I kind of came in, which is, hey, Microsoft, surely you have a tool, even if it's only in-house, and I spent quite a bit of time with them trying to get them to admit whether or not they actually knew how to do this. And then depression. We had basically been in this call with them for 60 to 90 days, and we're getting nowhere on this. So then that kind of led to the, okay, well, we're going to do something about it, right? We're not just going to sit around and do this. This was kind of the annoying scale of bug where it was like, or the annoying scale of problem where it's like, this wasn't shutting down our business. Like, we weren't shut down. So you're like, oh, but it's just enough that your users complain constantly about it. So it was this kind of like low-level harassment for like 3 months. So we fixed it, right? So we said, okay, I can do Python. So we wrote, there's an interface called the Windows Management Instrumentation. And so we built a client for it, which basically involves like sacrificing goats, like that. It includes my favorite comment I've ever written in a piece of open source software, which is, note, WMI returns the year 1601 or 9999 to indicate unfinished processes. I don't know why that is. That's kind of like the weirdest API ever. All right, it like hints at this like deep terribleness that's underlying this thing. Okay, and so now, like, I've discovered since then, I mean, this was a long time ago, that Microsoft has actually fixed this, and you get to use this delightful looking tool to monitor it. But the point here is that when we made the design decisions around selecting this as our way of syncing data across our organization, we failed to include monitorability as one of the primary requirements for that selection. And it burned us big time. It burned the organization a lot because in the long run, we ended up open sourcing this tool. Please don't look it up, it's terrible. It's embarrassingly bad code. We open sourced this, and I presented it to a Philadelphia Python users group, and the CTO of my last company hired me after that. So they lost me as a result of that because it was like, oh, I built this really cool tool, and I shared it with everybody, and they said, oh, we should get you. So in the long run, this was bad for our organization. Okay. Observability isn't just about monitoring and logging, though, right? It's also about how we build our software, right? So we should be building our software for rainy days. Anybody can build tools that work when everything is working, right? That's easy. If we only build for the everything is working case, then we're tying our hands when things go wrong. So let's tell a story. So we've got our startup. And I kind of wear skinny jeans here. So of course, we're going to write it in Node.js. And unfortunately, our first attempt at this has a programming bug in it. We'll get into what that is. Now, the right way to do this is to build the way that we operate our software for sane debuggability, right? So we're going to abort an uncaught exception, which means that we get a understandable error message, right? It's a type error. That's easy. And we get a core dump. So we can take our debugger, we can take that core dump, and we can load it into our debugger. This tool is MDB v8. So Joyent is a little crazy, and we build our data center software in Node.js. We were, for a long time, the corporate stewards of Node, and so that's where that relationship comes from. And so we've built this kind of tooling into our operating system. So we can take our debugger to find the stack in that core dump. So because this is a VM, right, and JavaScript is an interpreted language, like all the source code's right there. So we can go from the core dump and be like, well, where's the source that was associated with that right there? And then we can get the function for that exact line of code, and then we see kind of here at the bottom the object that created that problem, and we saw the error message, and we realized that, oh, we have an object here that wasn't expected. So we went from one bad request to the root cause, right? That's a really powerful way to build and operate software, right? It's not like, oh, well, let's run it through the logging for the next 6 months and figure it out, right? But we're a startup, and so we read Hacker News, and there was this really cool blog post on promises, so we decided to rewrite the whole backend in promises overnight. And there's no longer this idea of like automatic abort and core dump. And no, I want to point out, this is a programmer error, right? A type error is a programmer error. It is not like a esoteric I/O error or like something was flaky in the network, right? This is like you made a mistake, you have a type error in your code, right? In more robust languages with better type checking, you would just you would do this at compile time, right? This would never hit production. So we have to remember, so we have a programmer error here But in order to get the values, the values we need to debug this, we have to actually manually remember to do a process abort, right? Which is kind of funny, right? Because if we could remember to do that every time we made a programming error, maybe we just wouldn't make the programming error. But let's assume that we've done that. But now, because we're using promises, we've completely mangled the stack, right? So all our cool debugging tools that now have to deal with this extra complexity, and all this kind of like mangling. So even if we get that information, we can dig up the error message, but it's kind of like isolated, right? It's not associated with the code anymore. And so we have to kind of dig through the functions associated with that. We have to find all the closures that the then references, like promise then. And then we kind of have to go spelunking through the heap to find all the possible objects that might have been passed into this thing. And if you're using anonymous functions and you're passing those around, basically your answer to these things is like, guess, you're screwed, because it's just gonna be like anonymous as anon all over the place. But we're gonna cheat a bit here because the code base is really small and so we know where things are. And finally, we can print out and compare this against the error message and dig back to the source code and get realize how we screwed it up. So, wow, this was an awful lot more work, right? And we're a startup and we don't really have the time to do all this stuff, and we've created a lot more burden on ourselves. And you might be saying to yourself, come on, right? When Ruby, we just, if we're crashing more often because of this, it's not really a big deal, right? When Basecamp came out, they were restarting the Ruby on Rails server like every 5 minutes. That's like a literal thing. And that was fine, like they were very successful. So we're web scale, we'll just scale horizontally, it'll be fine. But that costs more money. So that's gonna increase our burn rate. We're gonna have to go back to our VC's lawyer, right? Which means that we're contributing to the bubble, right? And eventually, this kind of money is gonna dry up. And that's gonna start to have like larger effects on the global economy, not just the national economy, but the global economy, and that could lead to some really nasty things. And then before you know it, it's strapping on the power armor and fighting radioactive mutants and zombies and stuff, right? Okay. So of course, I'm not saying that promises are going to lead directly to radioactive zombies. What I am saying here is that we've made a seemingly small technical choice, right? For what is really just ergonomic reasons, and we've made it very, very difficult for us to understand understand the behavior of our application, and it's made it difficult for us to observe its behavior in production. I want to have a little aside here. If you don't know how to do this, or nobody in your organization knows how to do this, you should probably learn how or hire somebody who does. If you are a junior or mid-career type person and you're looking to level up your technical skills, like this is a great place to start for whatever your language is, right? Don't do Node. Whatever your language that you love is. And if you're on a platform where you can't even get access to this stuff, right? So, so this is, App Engine and Heroku and Beanstalk, right? You have no shell, right? You can't do any of this stuff. So I'm not saying never use a PaaS, right? That would be a very silly thing to say. What I am saying is that you do need to understand what you're giving up when you do that, right? If you choose a platform where your engineers are the people who are paying a lot, are inevitably going to run into a situation where they have to just throw up their hands and say, I guess we're just gonna have to call support on this. You might kind of introduce a culture of learned helplessness around understanding how your application behaves. So we should definitely take advantage of all these minor abstractions that we have, but we should be aware that they're abstractions, right? We need to know what's going on under the hood when things go wrong. And so I would encourage you all to err on the side of choosing for observability. And a platform just isn't where you're hosting it, it's also the tooling you're using, right? So I'm not saying that you shouldn't pick a language where their documentation says, well, debugging is hard, let's go shopping. But if you're going to do that, you should definitely know that you're making a trade-off, right? I'm picking on Go a lot because we at Joyent are adopting, I've written a lot of Go, and we at Joyent are adopting Go in some of our systems. And pretty much the first thing we did was say, how do we make this as observable as the rich tooling that we have for Node? This is James Nugent, one of our developers who's come to us recently from HashiCorp. And this is a dtrace PID provider. And so what he's done here, and this is kind of like the hello world of dtrace, he's got a running application, he's poked into it from the outside and said, stop and core dump when this function gets this argument. And so it does that and then resumes immediately, right? That's a really powerful tool. So we have a choice to understand what we've built. and try to understand what's normal, what the normal behavior of our application is, right? We have a choice to use our observability tooling all the time so that we have a lot of facility with it when things go wrong. And we can use this to build a culture of engineering excellence within our organizations. Or we can pretend we don't need to. And I know which organizations I would bet on. Okay, the last principle, building for responsibility. If you are not already annoyed with me, hold on to your butts. Every tool we choose comes with a community attached, particularly in the open source world. Some of these communities make it a point to be open, welcoming, inclusive. This is the Rust Code of Conduct. And I'm not saying you should all use Rust, right? Because I can't say choose boring technology and then say, go out and use Rust, right? Those would be opposite statements. But there's a lot to pay attention to here, right? From the very beginning of this project, they've decided that we want to make sure that we have an inclusive community. Other communities have kind of a well-deserved reputation for being toxic and hostile. I'm not going to call them out specifically. But we can choose which community we want to be a part of, right? Choosing a tool means choosing its community, particularly with the languages and frameworks we use, right? Your team is going to interact with people from that community all the time, right? Like you may have a great team, but your team is going to submit bug reports to frameworks. They're going to submit patches. They're going to read blogs about your software, the software choices that you use. They're going to attend conferences like this one. So if you can build the best team in the world, but if they're interacting constantly with a really toxic environment as a result of that, they're not going to, that may have a long-term impact on their happiness. The tools you select are also going to affect the people that you hire. If you select tools with deep roots in academia, you may find yourself hiring from the same pool. Now, if you are building very innovative, deeply innovative work, where knowing that a monad is a monoid in the category of endofunctor, I have no idea what that means, then maybe that's exactly what you want, right? But if you're building CRUD web apps, and you were to say, well, let's build them all on Haskell, and you hire a bunch of people who are really interested in that sort of thing, they're going to be really bored with your CRUD web apps, right? And this goes all the way down to the design of the tools that we use. If your programming language is intentionally designed with the idea that you're not smart enough to use a better one, I won't call out what this one is, but you can tell who it is, that may make you think about the community that you want to enter. This particular community is fond of saying that you're holding the phone wrong when it comes to your programming language, which I find to be really obnoxious. When a community not only tolerates exclusionary behavior, but a segment of the community decides we're going to fork this runtime over this principle that we don't care about this gender stuff, right? That says something really nasty about that community. Many of the systems that we build are ripe for abuse, right? Inclusivity doesn't just stop with your team. We have misaligned incentives around the way that we're building things. So I mentioned at the beginning of the talk, we have this kind of embarrassment of riches of tools, right? We talk a lot about JavaScript fatigue. People have heard that term, right? Like there's a new framework every week, and it's like, how do you even keep up with this stuff? And of course, to some degree, that's great, right? Like that's the victory of open source, right? Like anybody can make something new and toss it out into the world, and it will get chosen on its own merits, maybe. But have we thought about why we get why that happens, right? Like some of it is going to be this resume-driven development, of course. And just a quick aside on that, if you as a hiring manager, if your things are well, let's make sure they all have 5 years in all these new technologies, and this hard list of technologies for every job posting, you're encouraging this behavior, right? You're encouraging resume-driven development because everybody, to get a job with you, they have to be constantly on the bleeding edge. Well, they're going to want to bring the bleeding edge to you too, and if that is not compatible with the idea of choosing boring technologies once you actually get there. That's an aside. But perhaps another reason why this is happening is that the missions of our organizations are not enough for us, right? We're not being fulfilled by our work. We're not being fulfilled as makers, as builders, as creative professionals. So I'm going to ask a question here. Don't raise your hands because your bosses may be sitting next to you, right? Just give me stern eye contact if this is the case, okay? How many of you are working on something that makes the world worse, right? some uncomfortable giggles, that's okay. All right, so, and this can be for whatever definition you want, right? Like you may like say, I would never work on an ad product, like that would be horrible. And you over there may be saying like, I'm fine with ad products, but like bombs are right out. And there's probably somebody in the back with a beard, it's always a guy, who's like, well, bombs are okay so long as it comes with a GPL license, right? Like, but for whatever your definition is, right, okay. Now, okay, and then for this one, raise your hands if this is true for you. How many of you are working for organizations that are hiring? Okay, basically everybody, right? Left up without comment for a moment. I want everybody from that first group to go find someone from the second group during the breaks, okay? We're all hiring, right? Every one of us is hiring these days. And we as technologists are in huge demand right now. This is a seller's market. You do not have to work for a company where you are making the world worse. You can actually work for a place that is at least not making it worse, right? Maybe it doesn't make it better. Maybe it's kind of a neutral thing. Right. The work we do creates the community that we live in, right? It reflects our values. It reflects our blind spots too. Our blind spots is how we end up with companies like Facebook and Google saying, we demand your real names, which is very harmful to people who are trans, to people who are political activists, who are gonna be actively harmed by the giving up of their real names in public. It's how we end up with mobile sites that blow away the cheap data plans of working class users to send them a really giant ad for a product they can't afford. Our profession doesn't have licensing, which is probably right. Like there's a very large gap in the kinds of things that are involved in what it is to be a software engineer, right? Like someone who works on like embedded avionics, like does not have an overlapping skill set with like the person who does web stuff. Like those are not like the same thing. And not to say that one is harder than the other, don't ask me to write airplane stuff. That would be a very, very bad idea, right? So like, so given the diversity of skill requirements, it's probably fine that we don't have licensing. But I think that we can learn from our brothers and sisters in other engineering professions, right? So this is the American Society of Civil Engineers. What if instead of seeing this, imagine instead if we had a code of ethics like this, right? I'm gonna read this because I think this is really important. Engineers shall hold paramount the safety, health, and welfare of the public and shall strive to comply with the principles of sustainable development. Engineers shall act in a manner as to uphold and enhance the honor, integrity, and dignity of the engineering profession. That would be really cool, right? Like that's really different from this, right? I think we can do better. I think that software can improve our culture, and I'd like you to join me in starting today. Thanks.